free radical addition reaction. This is addition reaction which involves free radicals. Which involves free radicals. Okay. This free radical addition mechanism takes place in the presence of a peroxide. This takes place in the presence of peroxide like benzoyl peroxide. Okay, benzoyl peroxide. In the presence of this peroxide, the reaction takes place reverse to that of the Markovnikov's rule. Okay, so here we are following the free radical mechanism follows which rule? Anti-Markovnikov's rule. Okay, anti-Markovnikov's rule. And this reaction is taking place in the presence of peroxide. So, it is also called as peroxide effect or Karash effect. Peroxide effect or Karash effect. Okay. So, here we are following the anti-Markovnikov's rule, and according to anti-Markovnikov's rule, the negative side of the reagent will goes to that carbon atom containing more number of hydrogen atom, that is reverse or opposite to that of the Markovnikov's rule. Now, it is a three-step process. This free radical mechanism is a three-step process. Let us see one by one. First one is the initiation step. First one is initiation step. First step. Initiation step. Okay, initiation step. This is a two-step process. This is a three-step process. So, in the initiation step, since it is taking place in the presence of a peroxide, first peroxide is converted. Peroxide homolytic cleavage takes place and it gets converted into 2-RO radical. Okay, this is the initiation step. Also, in the case of HBr, this RO radical will combine with HBr. There also homolytic cleavage takes place and gets converted into ROH and Br radical. Okay, this Br radical is used for the next step. Okay, propagation step. Propagation step. Here, the substrate molecule, that is propene, CH3, CH double bond, CH2. This propene will react with Br radical and it gets converted into, and two types of radicals are formed. CH3, CH, either Br will come and attack here. Okay, so one radical, and here, or Br will come and attack here. So, second radical, CH, Br. To be. Okay. So, here in the presence of the peroxide, this reaction taking place. So, the radical obtained will be according to the anti-Markovnikov's rule. That is, Br radical will goes to the carbon atom containing more number of hydrogen atoms. So, first, second. So, it will follow this second molecule. So, the third step is the chain termination step. Okay. In the chain termination step, this radical CH3, CH2Br. Okay. This radical will react with HBr. Again, homolytic cleavage takes place. Okay. Now, it gets converted into CH3, CH2, CH2Br. So, this will be the product in the case of free radical mechanism. Next, two Br radicals will combine and form Br2. This will be the chain termination step. Okay. Now, in the case of HF and HCl, the reactivity is very less because the cleavage will not take place easily, because in this case the bond energy is very high. Bond energy is maximum. So, it is difficult to cleavage and form the free radical. So in the case of HF and HCl, this reaction, this free radical mechanism will not take place. But in the case of HI and HBr, the bond energy is less, minimum. Okay. So reaction takes place in the presence of HI and HBr. Okay. So this much about the free radical addition reaction.